Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about extended Euclidean algorithm. In our last class, we discussed the basics of discrete mathematics. There we have discussed about we are going to use Euclidean algorithm to find the GCD value. This is an extension of Euclidean algorithm. The same formulas we are going to use here, but what's this extended Euclidean formula and how we are going to use this, where we are going to use this will be discussed in our coming classes. First we are going to understand what's this extended Euclidean algorithm in this class. So please watch our previous class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so in order to find the GCD of A comma B, A is the biggest value, B is the smallest value. If you want to find the GCD of A comma B, this is the equations which we used in our Euclidean algorithm. X is equal to, X is the remainder value. X is equal to, X1 means A, X2 means B. X1 minus Q means quotient value. X1 minus Q, X2. This is the formula we use it to find GCD using Euclidean algorithm. Similarly, once you find this formula, once you find the remainder value, X2 will become X1, X will become X2. Again repeat this formula until you get the remainder value 0. This is what we have done in finding the GCD value using Euclidean algorithm. Yes, GCD of A comma, okay. So now let's take an example, 161 comma 28. What is the GCD value? 7. Similarly, now let's try to understand what is extended Euclidean algorithm means. GCD of A comma B means 161 comma 28 is 7. 7 equal to means 7 can be written in the form of A and B. A multiplied by some constant, that constant we call it as S. B multiplied by some constant, that constant we call it as T. Yes, any GCD value can be written in the form of A and B. Why it is possible to write the GCD value in the form of A and B? Because GCD of A comma B here is 7. 7 divides A. That is what GCD means, greatest common divisor. 7 is going to divide A. 7 is going to divide B. If it is divided means you can use a multiple value. You can use multiplication value and multiples plus and minus symbols. You can write the 7 using A and B. Because 7 is going to divide A, 7 is going to divide B. Yes, we can write. This is the basic division and multiplication values from our +1 +2 mathematics. So that's why GCD of A comma B can be written as some constant multiplied by A and some constant multiplied by B in between plus. This is how we can write the GCD value. So finally, in the extended Euclidean algorithm, we are going to identify this S and T values. This is what we needed. Why we needed these S and T values? We are going to use this in our coming classes. First, try to understand how we are identifying these S and T values. See, in this example, 161 comma 28, GCD of 161 comma 28 is 7. Now 7 can be written as minus 1 multiplied by 161, A is 161 plus 6 multiplied by 28. You got it as S is equal to minus 1, T is equal to 6. So S value is minus 1, T value is 6. So like this you can write a GCD value in the form of A comma B. In that we need S and T value. Now coming to understand the formulas which we are going to use here. Just remember the formulas. You are going to understand with an example here. So here the same formula, X is equal to X1 minus Q X2. Q here is quotient. X means remainder value. The same formula we are going to use here. S is equal to, S is remainder value, equal to S1 minus Q S2. Here S1, S2 initial values we have to assume. Which initial values we have to take? All these things will be discussed here when we discuss the example. So while doing the when we are finding the GCD value, along with that, if you apply the formulas, we are going to identify the S and T value also. So this is the equation we are going to use to find the S value. Once you find the S value, S2 value will become S1, S value will become S2. Similarly, X2 value will become X1, X will become X2. The same formula we are going to use. Similarly, T can be identified using T is equal to T1 minus QT2. Here T is the remainder value, T1 and T2 are the initial values we have to consider, Q is the quotient value. Once you find the T value, remainder value, T2 will become T1, T will become T2. So using these equations, we are going to identify the S and T value along with finding the GCD value. That's why it is called as extended Euclidean algorithm. We are using the same, but we are going to extend it to find the S and T value. Now coming to the example, initially X1, X2 values are 161 and 28. So initially S1, S2 values are 1 and 0. T1, T2 values are 0 and 1. So first we need to find X1, X2, apply this equation, X is equal to, we need to find the remainder value, X. Here we got 21, that's why for understanding purpose, we have circled it. How we got that? X1 minus quotient multiplied by X2, 28 5s, 140, 161 minus 140, you are going to get 21. Similarly, S1, S2 value, S is equal to, here, S1 minus quotient multiplied by S2. S1 here is 1. 1 minus quotient 5 multiplied by S2. What is the S2 value? 0. You are going to get 1. Remainder value is 1. Similarly, you need to identify T. T is equal to T1 minus QT2. Initially T1 is 0, T2 is 1. T is equal to T1 0 minus quotient 5 multiplied by T2 which is 1. So 0 minus 5 which is minus 5. That's why our remainder value is minus 5. So the first line has been finished. Now X2 will become X1, X will become X2, S2 will become S1, S will become S2, T2 will become T1, T will become T2. Again apply these formulas. Again identify the S value, T value and X value. The second line, the X value is 7, S value is minus 1 and the T value is 6. Again repeat. Now X2 will become X1, X will become X2, S2 will become S1, S will become S2, T2 will become T1, T will become T2. Again repeat. How long we have to repeat this? Until you get the remainder value 0. That is what we used in finding the GCD. Once you got 0 here, in the third line we got remainder value is 0. Once you got 0 in the next line, no need to continue. Just follow this. X2 will become X1, X will become X2, S2 will become S1, S will become S2, T2 will become T1, T will become T2. Now GCD value is 7, S value is minus 1, T value is 6. See here, GCD value is 7, S value is minus 1, T value is 6. We are going to identify S and T values. So in our coming classes, we are going to use this S and T values. Where we are going to use this, that we are going to discuss in our coming classes. Whenever it is required, we are going to discuss that in our cryptography basics. Hope you understand how to find the extended Euclidean algorithm to find the S and T values. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.